going to be talking about moor dung and dung beetles and how different grazers can affect the activity of greater horseshoe bat. So, as mentioned, the aim of the project was to find out if greater horseshoe bat activity is affected by different grazing methods, by looking at the bat activity in different fields and the dung beetle abundance within 5 differently grazed fields at the donkey sanctuary in Sidmouth. So the reasoning behind the project was that agricultural intensification is a major cause of biodiversity decline, particularly to keystone species like the greater horseshoe bat. And keeping traditional sort of farm management and grazing regimes are integral to the persistence of greater horseshoe bats and their prey species, such as dung beetles. There's a lot known about greater horseshoe bat foraging over cow grazed pasture land, but not as much is known about how other grazers affect bat activity. And the donkey sanctuary in particular were interested in seeing how donkey grazing affects bat activity. So the sanctuary presented an opportunity for comparisons to be made between different types of livestock grazing and greater horseshoe bat activity in a non-intensive agricultural environment. The sanctuary is fields within a valley system which are grazed by donkeys, sheep and cows, which was very kindly the field provided by an adjacent landowner. It's also quite an important area as there is a known maternity roost in Branscombe about 4.2 miles away, so it's potentially quite important habitat for the bat. So this is a map of the site showing the different fields that we have. They are all in quite a good proximity to each other. So the 5 treatment types were cow grazed, sheep grazed, donkey swept, unswept, and an ungrazed field. The project ran from May to July in 2018 with an bat detector set up in each field for 2-week periods each month, and moved to a new hedge line every 3 days to account for field margin bias and just to get the best possible results of picking up the bats. And at each visit, I'd collect dung samples from each of the grazer field, which I'd submerge in water to collect and count the dung beetles to ID where possible. So data was collected from each bat detector every 3 days in each survey period and processed through untitled to analyse the bat calls. And dung beetles were collected from the dung using the flotation method and a handmade net. To either ID the beetles at the time, or they were frozen, unfortunately, and ID'd in the lab. So I expected more or less to find more bat activity in the cow graze field just due to the previous studies and because on site of the dung there were more sort of larger beetle species and a bit more diversity within the cow dung. But what I actually found was that there was there were more activity and dung beetles in the sheep graze field, and that there was indeed a significant difference of greater horseshoe bat activity and beetle abundance in different fields. So as mentioned, there were more in the sheep graze field, and the lowest occurrence was found in the donkey grazed swept treatments. And this is just some data to show that the sheep graze field did have quite a larger difference compared to the other fields, both for greater horseshoes and dung beetle abundance. So potential explanations for the results was the cow graze field, the herd was actually rotated between 2 different fields, and previous studies have suggested that bats forage more over fields with herds rather than empty pastures. The sheep were within the same field and had a much larger herd, which perhaps also links to how stocking densities may promote more bat activity. There was also a higher beetle abundance in the sheep graze field. Sheep tend to graze in smaller clusters within the herd, leading to a much quicker renewal of dung in smaller areas. Or it could simply be that the sheep graze field had much better connective features. It was quite good sort of tree corridors surrounding the field, hedgerows, and small clusters of trees, making it potentially a better foraging environment. But I do also have to say that there was a loss of data from the anabat in the cow field over a 3-day period, so that did skew the data a bit. So despite there being more beetles and bats in the sheep graze field, there was no significant relationship between the horseshoe bats and beetle abundance. It could just simply be due to a lack of replicate fields, or it could be due to selective foraging of Lepidoptera over Coleoptera, which could account for why there were more average flyovers in the un-grazed treatment compared to the donkey grazed and cow grazed fields. So implications for land management recommendations. So I think it does help highlight how preservation of non-intensive farms is vital for preserving dung beetle and greater horseshoe bat populations, particularly preservation and restoration of linear habitat features and non-intensive grazing regimes to help maintain both ends of the food chain. So further research, I think replicate projects over multiple survey sites are needed to discount or prove a correlation between greater horseshoe bats and dung beetles and grazer. Nocturnal surveys, I think, would also be of use with the addition of handheld full spectrum detectors to ascertain if there's a feeding buzz, just to make sure that there is actually foraging going on in those fields rather than that they're just in the commuting pathway. I also think it would be beneficial to map the ecological features of the area to highlight the potential commuting pathways and the importance of physical landscape diversity, preserving the habitat features. And thank you for listening.